That's probably fine, yeah.
Back pocket, it's green, it's on.
It's on, yeah. Perfect.
So we're starting the next talk in like 20 seconds. If you're moving out, please go out now. If you're staying, find a seat.
Please stay.
Walk out.
Okay, cool.
Give it 20 seconds to let down.
Yeah, I guess I have to stream. Is it? Yeah.
Almost no amplification. And we cannot fix it.
Yeah, it's weird.
Yeah. For the recording and streaming, this is perfect. For the room,
Yeah. Maybe that's better.
Okay, we're starting with the next talk. So Max will be talking about how to go from zero to portability.
Hello. So, yeah, my name is Max, and I'm a software engineer at the Beam project. And I want to tell you about Beam today and how Beam realized its vision for portability. And what do I mean by portability? Because portability can mean a lot of things. Well, first of all, you have to listen carefully to understand, but hey, Colton. But the short answer is that it enables you to run your data processing jobs on top of various execution engines like Spark or Flink or Samza or Google Cloud Dataflow. And you can do that in the programming language of your choice. So that sounds pretty good, doesn't it? So I've put this agenda together. So first of all, I mean, some of you might know Beam, but I will give a short introduction. Then we will talk about, a little bit more about portability, and then how we can actually achieve it, because there are multiple ways to do that. And then let's recap and see how far we are actually with portability. So what is Beam? So first of all, Beam is an open source project at the Apache Software Foundation. So I don't know if you know the Apache Software Foundation, but it's like a framework for developing open source software, which they provide infrastructure and kind of a guide how to develop software in the open source. And Beam is a project there, and it focuses on parallel and distributed data processing. So you typically run your Beam job on like multiple machines, and you have mostly large data, but you can also run it on a single machine if you want. And it has a really cool API which can do batch and stream processing at the same time. So often like you have like a batch and stream API which are separate, and you have to like port your batch job to streaming, but in Beam it's all the same. And once you've written your job, you can actually run it on like multiple execution engines. That's why sometimes we say it's like an Uber API, because like you use one API, but you can execute with multiple backends or execution engines. And now you can also use your favorite programming language. So a little bit more detail on this. So we have, this is the vision of Beam. We have the SDKs here on the left side. And so that's like Java, Go, Python, Scala, and SQL. And then we have some magic happening in Beam, which are the runners. There's a runner for every execution backend. And the runner translates the Beam job in the SDK into the language of the execution engine. And you can see there are a bunch of them, and more are coming. And yeah, that's really nice to have that choice, right? So how does the API work, like just concept-wise? So in Beam, they're called, there are P collections. So first of all, there's the pipeline. The pipeline is like the object that holds all your job information. So you create that from some options which you can pass in there. And then you create P collections. P collections are created by applying transforms to the pipeline. So you do always like apply transforms. So it's really easy. And this can be like, you can do multiple transforms after each other, or you can also branch, like here where you create this pcall2, which is like, a branch of pcall1. And then you can run that pipeline. That's pretty sweet. So transforms are actually quite a nice abstraction, because transforms can be either primitive or composite. What does it mean? Actually, in Beam, we only have a few primitive transforms. We only have like pardo, group by key, assign windows, and flatten. So I will explain two of them in a bit, but so basically what that means, you can define like composer transforms which use these, and then these are actually the composer transforms like expanded to these primitive ones, which is really easy because we just need to, I mean, as a runner creator, you just need to implement those for primitive transforms, and we can do optimizations for composer transforms, but it's enough to implement that primitive transform. So of course, because this is like a big data framework, we have to do a little word count. And for those of you who don't know word count, it's basically you have a list of words like to be or not to be, and you try to count how often like a unique word, distinct word appears in that list. The way to do that is to use, if we are talking about Beam, then you use a par_do, which stands for parallel do, and you would assign like a key value. You would transform your words into a key value object with like a 1, which stands for number of occurrences. And then you would do a group by key, which basically shuffles the data and gives you a list of all the values for every distinct key. And then you can sum them up, and you know that 2 is twice in this list, and B also, and the others just once. So don't get confused now. This looks really ugly. This is actually how you would do it in Beam, but we will see we can simplify it a lot. So we have the pipeline. We have our list of words, in this case, like hello, hello, FOSDEM. And we have this par_do, this first one, which assigns like the 1. And then we do a group by key. And then we have this loop here in the second par_do, which sums it all up. Yeah, I mean, that was pretty ugly. I agree. I mean, I don't know a better way to write this any non-comprehensible. So luckily, we have composer transforms. So we can simplify this now further. So instead of doing the first par_do, where we do this do with end function, we just use a map elements function, which is slightly more simple. And we do like an integers per key composer transforms, which does basically, it sums up the value, the number of occurrences for each key. And we can simplify this even further by just using this count per element composer transform. So that looks pretty simple, right? So there are a lot of these transforms in Beam, and if you read the documentation, you can write really readable code, even in Java, because that is a Java API. We have, of course, fortunately also a Python API, which looks so much nicer. So here, this would be the same initial example. We just use lumber functions to that word count. And also in Python, we have, of course, these composer transforms. So this is maybe slightly simpler, where we have the combine per key function, and we pass sum as an argument. This is just like a very quick look into the Beam API. I thought it would be useful. There's lots of more composer transforms. You can create your own. We have lots of I/O. We have windowing, event time, watermarks, side inputs. I mean, state and timers, it doesn't make sense to you at the moment, maybe if you haven't tried it, but it's really useful concept once you learn more about Beam and your pipeline gets more complicated. So what does portability mean now? I mean, I showed you Java, I showed you Python. That should already be working, right? So let's see first, what are the two different kinds of portability in the Beam context? So we have the engine portability, which is like the ability to run it on different execution engines. And we have the language portability, which is like using different SDKs for composing the pipeline. And if we look back at the vision, which I showed you at the beginning, this is really, how it should work, right? And in terms of engine portability, it is actually true. Like, if we are in the Java API, we just, these options would we pass to the pipeline. We just set runner, Flink runner, and then we do run, and it really runs on Flink. That's pretty amazing. So we have that part covered already. Now, what about language portability? Why would we use other languages? Well, it's kind of, clear, I guess. Syntax expressive communities is a big point because there are a lot of people who simply don't like Java for various reasons, which I can understand. I mean, I really like Java, but it's okay. But we also have a lot of libraries, which is like an important factor. Like TensorFlow are really like huge libraries which are simply not available in Java. So that's a good reason to use Python. So I was actually lying a bit to you. This whole portability, language-wise, doesn't really or didn't really work. So it used to be the case that we just, basically only were supporting Java and Scala in the open source world, and we had like, when you used like the Google Cloud, you could run Python, which is like not so cool, right? I mean, it kind of breaks the promise. So what we need is, and what we worked on in the past like almost 2 years, is to build a language portability framework into Beam and its runners, so that we actually can do realize the full vision. So how do we achieve it? If we look at sort of the very abstract translation process of a pipeline, it used to be like this, where we had Java and then a bunch of runners, and they all executed in Java, so they need to implement their own translation way, but once they translated, it was fine. Now that we have language portability, it seems like well, maybe not very good idea, but it's certainly possible to just, let every SDK figure out a way to translate to every execution engine, and then the execution engine has like their own various ways of supporting that language. But that just seems like a terrible idea, very complicated and replicating a lot of work. So what we did is we introduced the runner API, which takes the pipeline from the SDK and sort of transforms it into a language agnostic format. It's called the runner API. So it's based on protobuf. I mean, it doesn't really matter. It's just like a format that is consistent across languages. So, and then what we also needed is, during execution, we have like these language-dependent parts. Like when the execution engines, most of them are, actually all of them are written in Java. So when you have Python, you need to figure out a way to send data to that Python process and access state and on all that. And this is called the FUN API, FN API, yeah. And that way we pretty much only have these 2 extra layers and just have to make sure the runners are compatible with that, and then we're good to go. So let me simplify this a lot. So we have the old way was like we have the SDK and the runner, and we have, for example, an execution engine like Flink with a bunch of tasks, and all these were in Java. So, and that worked pretty well. The new way is a bit different. So in the new way, we have the SDK here, which uses the runner API to produce this universal pipeline format. And then we actually have the job API, which is a way to send this pipeline to the job server. And the job server is really a Beam concept now. It used to be that every runner had, every execution engine had its own way of submitting applications. But we wanted to, really get everything portable. So we created the job server. And in the job server, the runner translates this runner API pipeline. And then it executes it on the engine of your choice. But, of course, we have these like Python blobs or Go blobs in between, which we don't really understand. And whenever we have that, we have a special task called executable stage, which is a fancy name for we don't know what to do with this, so we have to send it to an external process, which is called the SDK harness. And that harness exists for every language, like for Java, Python, and Go. So whenever we create the harness when we start a job with the Python code, for instance, and then whenever we receive data in that task, we send that to the external process. The external process does its processing and sends that back. It's very simplified. And there's some challenges to that because there is not a great cost, but there's some costs when you send data to an external process, right? Because you need to serialize that data and deserialize it again. So we built in some optimization called Fusion, which tries to combine as many of these Python stages, for instance, into one SDK harness. So we don't do any like the duplicate serialization work. How does the SDK harness work? So first of all, the SDK harness needs to be bootstrapped somehow, right? So what we typically do is we use Docker. So we have an environment which contains all the dependencies like my TensorFlow or my NumPy, and use this Docker image directly. We can specify that in the options. That's a really easy way of deploying because you have an image registry and you just download that image automatically and start it. But some people don't want to use Docker because for various reasons. And so you can also start like a process-based execution, but then you have to make sure you set up the environment, the environment like manually. And it's also possible to run this embedded in case you're using Java. And so there's a lot of happening, a lot of communication between like the backend and the SDK harness. Like obviously we need to control, like we have like control plane, a data plane, we have a way to access state and report progress and also logging. I mean everything is logged, so you know actually what is happening inside that external process, because otherwise debugging it would be really hard. So what is now missing is, and kind of a problem, it is not only, I mean, a runner is like a SDK is only complete if you can read and write data, right? Because it's not really worth anything if we can support all the primitive transforms. We also have to be able to actually have that connectors, which we have in Java, in any SDK available. And you can see there are a lot of them available. Now, it would be kind of a lot of work to replicate them, and the language support, for example, when you want to create a Kafka connector in Python, the language support is not so good. In Java, it's really good. So ideally, we would just use the Java connector in Python and not recreate it in Python. And turns out we can actually do that, and that's a pretty amazing solution. We can simply use that process, which I described, to run cross-language pipelines. So how does it work theoretically? I mean, we're finalizing like the specification at the moment, but it's sort of like this. So you have a Python job, and I mean, probably it's not going to be named IO expansion, but it's kind of like a dummy object where you specify your IO, like Kafka IO, or maybe the full Java name. I mean, it will be made a bit simpler, and you pass some configuration. And then, of course, I mean, Python doesn't understand this, but when we do the translation to the runner API, we actually have like an expansion service, a Java expansion service running, if we want to, in the case of Java. And so we take that stub, this placeholder, and expand it into like a native Java Kafka transform. So, and then when we do the rest of the translation, and when the job runs, we actually have now two different kinds of SDK harness running. So we have a Java one for our Kafka source, and then we have maybe some Python data processing afterwards where we do some map and count, and we of course also have the native native Flink or whatever you're using execution engine transform, like a group by key, which just doesn't need an SDK harness or anything because it's supported by the execution engine. Yeah, so this is sort of how portability works. There are a lot of details, of course, but it's a 20 minutes talk. How far are we? So we have the engine portability, and we have the language portability. Almost, I would say. I mean, for developers, you can try it out yourself. I have a link for you in the end. You can try it out. It works. We just have to make it a bit better. You know, there are some like we have to tune a bit the performance, although we have estimated 5 to 10% only overhead in most cases. And then, of course, language pipeline support needs a bit more end specification, but that's going to happen in the next weeks. There's also this fancy thing called splittable doFN, which you can read up, but that's not so important. There's a compatibility matrix, which tracks like the status for portability of all runners. There's a link here, and Flink actually is like the best runner, I would say, because it supports most features at the moment. The others are going to catch up. And that brings me to the end of my talk. Please check out the Portability website, or just go to the normal Beam website if you want to learn more about Beam. We have mailing lists and an awesome Slack channel, which is where there are a lot of helpful people. Yeah, and that's it. Thank you.
Any questions for Max? Yes. If you're moving out, please be quiet.
If we look at the actually think about they support different languages, but having different languages compile to common bytecode, they are quite successful in that.
Compile to what? Sorry.
Common bytecode.
Common bytecode. Yeah, so the question is, why not use something like Apache Tinkerpop, which uses like an common intermediate format between the languages, and then, or which is like bytecode, which can then be executed. There are a lot of other frameworks which do that. For example, Flink has a Python API which uses Jython, which is sort of like the same idea. You can generate bytecode from Python. We want to be able to support all kinds of libraries, like TensorFlow, which is like a native C library, and that you can only achieve if you run like a C Python interpreter and not like some custom version of Python which only supports a subset of Python. That's the reason.
Thank you. My question is related to that. If you have a multi-step process associated to execute code, if I write something in Python that is incorrect at one stage in the pipeline, in this multi-step translation process, do I find that it's wrong, that the syntax is incorrect? How is the debug experience like, basically?
I have, so yeah, I repeat the question. So how is the debugging experience like in these Python libraries? When you run into an error in Python, like how fast do you see it when you execute on a well, essentially Java runtime? It's actually pretty good, and it's been part of the design. So when in Python you see an exception, it will be like forwarded directly to the like Java operator, and it will catch an error there. And so, you due to the logging and stuff like that, you actually see immediately and the error is also sent back. So you see the error message immediately there, and your pipeline will fail, because if the runner receives a failure, it should fail. Yeah. Huh. Good question. I'm not working on the... Yeah, so the Python 3, is it supported or not? It is supported, but it is like 99% done. So it is there. You can use it. There are test cases and everything. It's just not, officially been released, because I'm not working on the Python side myself. So I expect it to be done actually in the 2.11 release, which is the next Beam release. Should be out next month. Yeah.
One more question? No? Okay, thank you, Max.
Thank you.